Good morning dear students, welcome back. I am your physics professor Dr. Nagaraj. So with this video I am going to start with numericals on physics of animation. I have already uploaded videos on numerical problems from quantum mechanics chapter and it has been well received by you people. So I hope the same support will be given to even this module also, and so in subsequent videos I am going to do numericals on other topics like superconductivity, conduction of electrons in solids, that is conductivity of metals, and lasers and optical fibers. Okay, now let us come back to physics of animation, numerical number 1. Here is the numerical problem. Question number 1, given the base distance is 0.5 centimeter for the slow out process, calculate the distance between the following frames using odd rule multipliers. See, you will get the numericals only on odd rule multiplier and jumping magnification concept. So here is one such question. You have to find the distance between 4th and 5th frame and 1st and 2nd frame. Dear students, I have already explained in detail about the use of odd rule, application of odd rule. See, you can solve this problem in two methods. Number one, you can make the chart. Well, I will explain only for one problem. For remaining problems, you follow this chart. Okay, na? So this is the chart which consists of three columns. First column is a frame number. I write it as A. Second column is B, that is distance between two successive frames. Please follow my notes. This is available. And third one is C, that is distance between first and present frame. Present frame. Okay, now let me write the frame number 1, 2, 3, 4, 5, 6, 7, because totally 7 frames are there. Between first one and first one no distance, first one and first one no distance. Okay, first one and second one, the frame distance is odd multiple of base distance. Dear students, this is the base distance 0.5, so it is 1 into 0.5, that is 0.5. And this is 0 distance. Well, now the total distance is 0 plus 0.5, that is equal to 0.5. Second distance 3 into, that is from 3 to 1, 2 to 3, distance between 2 to 3 is 3 into 0.5, that is nothing but 1.5. Now the distance is 1.5 plus 0.5 plus 0, that is nothing but 2. Now between 3 and 4, it is 5 times of base distance, that is equal to 2.5. Now the total distance is 2.5 plus previous distance. Just because of the shortage of space, I write only 2 directly. Actually I should write 1.5 plus 0.5 plus 0, so that is equal to 4.5. Now distance between 4 and 5, it should be 7 times. 7 is the next odd number, that is nothing but 3.5. Next it is 3.5 plus 4.5, that is nothing but 8. Okay, so next between 5th and 6th, it is 9 times 0.5, that is nothing but 4.5. So next it is 4.5 plus 8, that is nothing but 12.5. Now comes 6 and 7, it is 11 is the next odd number, 11 5s are 555. So next it is 5.5 into, not into 12.5, that is nothing but 18. Okay, 18. Well, now for us, what is required, that only I will encircle. See, I want the distance between 4th and 5th. So distance between 4th and 5th, it is 3.5. Correct? Next, distance from 1 to 7, distance from 1 to 7, that is from here to here, 18. So this is the answer. So 4th and 5th, the gap is 3.5, 1 and 7 gap is 18. This is one method, that is from the table. From the formula, how to find out? See, actually for question number A, I want B. B is equal to, please recall, it is 2 into A minus 1 whole thing multiplied by base distance. Okay, now sir, what is A here? See, I want 4th and 5th, therefore I have to put A is equal to 5. If you want the distance between 3rd and 4, you have to put A is equal to 4. Okay, so B is equal to 2 into A is 5 minus 1 into base distance is 0.5. So dear students, simplify this. It is 2 into 5 minus 1, 4 minus 1, okay, 3 into 0.5, that is, oh, somewhere I have done the mistake. 5 minus 1 is not, okay, sorry, this 2 is not here, this 2 is here, sorry, 2 is here, okay, just 1 minute, small mistake I did. This 2 should not be kept outside, right? Okay, now the simplify. B is equal to 2 into 5 minus 1 is 4 minus 1 into 0.5, that is 2 into 4 8 minus 1 into 0.5, that is 7 into 0.5, so that is 3.5 centimeter. See, this is what I have even in the table also. So look at this answer, correct? Well, that's all. Now coming to the second calculation. Second calculation is about C. You know, C is equal to A minus 1 whole square multiplied by base distance. Okay, well, substitute for A. What is A here? A is 7, 1 to 7, put A is equal to 7, then C is equal to 7 minus 1 whole square into B, that is 0.5, that is 6 square into 0.5, 6 square is 36 into 0.5, it is nothing but 18 centimeter. So I hope you got it. See, whichever method you adopt, you will get the marks. Either odd rule multiplier table you can use, or you can use even the equation also. Well, I hope you got this problem. Now let us proceed further with the next question. The next question comes here. Given base distance is 1 meter, so base distance is 1 meter, for slow in process. Calculate the distance between the frames 2 and 3, 1 and 4. Well, same, now I will use the formula. First question, I have to find out capital B. It should be 2 into A minus 1. So here it is minus 1 separate. Let me write it distinctly. Base distance is, wait, sorry. 2 into A minus 1 into base distance. Now what A value I have to put? Put A is equal to 2 to 3 alwa. So therefore A is 3. Therefore B is equal to 2 into 3 minus 1 whole thing multiplied by base distance is 1. So that is equal to 2 into 2 minus 1 into 1. So that is 4 minus 1 into 1. So that is 3. 4 minus 1 is 3. 3 into 1 is 3. 3 meters. So this is the answer for first part, that is second and third frame. Now coming to second question, 1 and 4. 1 and 4 means first one and the last one. So it is C is equal to A minus 1. C equals A minus 1 whole square into base distance. What is A value here? It is 1 and 4. Therefore I should put A is equal to 4. Therefore C is equal to 4 minus 1 whole square into 1, that is 9 into 1. So it is 9 meter. So that's all about the next question. I hope you are following. Now let us go ahead with the next question. So the next question comes like this. While animating a speeding up car, the total distance traveled is 6 frames in 25 meter. Calculate the base distance. So base distance question mark. Total distance I will take it as D, that is 25 meter, and frame number X is equal to 6. You know the formula, base distance is equal to total distance divided by number of last frame minus 1 last frame minus 1 whole square, that is d divided by x minus 1 whole square. So therefore b is equal to 6 divided, not 6, 25, sorry, 6 is the frame number. So 25 divided by 6 minus 1. So it is 25 divided by 6 minus 1 whole square. It is 25 divided by 5 square, that is 25. So base distance is 1 meter. So very simple problems, only on odd rule multiplier, and of course jump rule, jump magnification. Next question, a slow in object in an animation has the first frame distance of 0.5 meter and the first slow in frame is 0.35 meter. Calculate the base distance and number of frames. Dear students, I just explained this. Actually, I should have explained this in the regular video itself. Well, I forgot to mention this. See, this is a slow in process. Initial frame is here. I don't know what number, some x number, but it must be odd number. Next will be here, next will be here, next will be here, next will be here, like that it slows down. Okay, so here to here, sorry, not, this is not the odd number, this gap is odd multiple of some distance. Next here to here, this is the first slow in distance. So as per the question, this distance is 0.5 meter, first slow in is 0.35 meter. Okay, now I have to find out the least distance, that is base distance. Remember, base distance is also given by this equation. One feature of the odd rule is that base distance always half the difference between, half the difference between what? Difference between any two adjacent frames. Any two adjacent frames. See, this is the distance between these two, this is the distance between these two. Therefore, this and this difference I have to consider. So base distance is nothing but 0.5 minus 0.35. ಇದರ ಡಿಫರೆನ್ಸ್ ಇನ ಹಾಫ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ, half the difference between any two adjacent frames. So that is 0.5 minus 0.35. What is this? Let me do it. 0.5 minus 0.35 is 0.15. That divided by 2. That divided by 2 is 0.075. 0.075 meter. This is the base distance. Okay. So please remember this statement. This statement I should have mentioned in the regular video itself. I forgot to mention. Next, another equally important statement which also I should have mentioned in the regular video. To figure out how many frames, I want to find the number of frames. Say A, in slow in process, divide the first distance by the base distance, so that you will get the frame. But the answer whatever you get should be odd number, otherwise you have to approximate it to next odd number. What I mean to say, first distance is 0.5 divided by base distance 0.075. If I do this, I get some number. That number must be odd. This is not base distance, sorry, frame number. This is frame number. So do this calculation. So A comes out to be 0.5 divided by 0.075. It is 6.66. I told you, it should be odd number, so approximate it to next odd number. So it is 7. Therefore A is equal to 7. So these two sentences are quite important and they are applicable for slow in process. So this problem is quite important. This is mentioned even in the model question paper also. I hope you followed this question. Well, with this I move on to the next one. Here comes jump concept. In case of animating a jump, push height is 0.5 meter. Please write push height is equal to 0.5 meter and jumping magnification is 5. Calculate jump height. Jump height is equal to question mark. Acceleration due to gravity is given as a 10. You have to calculate push acceleration also. Push acceleration also question mark. So first part, jump magnification is equal to jump height definition, jump height, jump magnification is jump height divided by push height. So I want jump height. Jump height is equal to jump magnification into push height, that is equal to 5 into 0.5, that is 2.5 meter. So this is jump height. First part is over. Second part, jump magnification is also given by push acceleration divided by acceleration due to gravity. Therefore, push acceleration is equal to jump magnification into g, that is 5 into 10, that is 50 meter per second square. This is push acceleration. So I hope you got this question. So this is on the concept of jump magnification. Well, with this I move on to the last question from this chapter. Jump animation is associated with push time 5 frames. So see, the time is not given in terms of second or minute, but in terms of frames it is given. Okay, anyway, push time is given as 5 frames. Okay, well, next what is given? Push height is given. Push height is given as 0.4 meter. Stop height is also given, it is 0.5 meter. I want stop time. So there are two parts. Only first part I explained, till here I explained. Second part I will take up later on. Well, once again, please recall, jump magnification is given by push height divided by push time, that is equal to stop height divided by stop magnification. Stop magnification. Oh, sorry, I made a mistake here. Not stop magnification. Stop time. Okay, I want this, both are jump magnifications only. Actually, both are jump magnification only. So now stop time, I want stop time is equal to stop height into push time divided by push height. Substitute. Stop height is 0.5, push time is 5, push height is 0.4. So simplify, this comes out to be 2.5 divided by 0.4, 6.25 frames. Okay, this is one part. So I have stop time in terms of 6.5 frames, that is in terms of frames. Push time also in terms of frames. Now let us see the second part of this question. Express push time and stop time in second. If the animation is played at 30 fps, andre we have to convert frames to second. That means number of frames in 1 second, 30. So 30 frames is equivalent to 1 second. Therefore 1 frame is equivalent to 1 by 30 of a second. Therefore 5 frames, that is push 5 frames is equal to 1 by 30 into 5, that is nothing but 5 by 30, that is 0.166 or 167 second. So now I have push time in terms of second. Similarly, 6.25 frames is equal to 1 by 30 into 6.25. How much it is? 6.25 divided by 30, that is 0.21 second. So this is a stop time. So push time, therefore push time is equal to 0.167 second. Stop time is equal to 0.21 seconds. So that's all about this question. Well, dear students, with this I have come to an end of numericals on animation. I have covered sufficient concepts on animation, both odd rule multiplier as well as jumping magnification. I hope these problems are sufficient. Please go through and try to find out few more from other sources and practice. I will come back to you with some other numericals on superconductivity in my next video. Till then, thank you very much. Please like my videos and share with your friends.